To inspect the current and historic quality values that we have measured for our atomic monitoring, and to give the, for example, the city stakeholders and the municipality and the owners of the data streams an idea about the quality for their sensors and data streams, we have developed this CityPulse Quality Explorer that you can see now. This tool allows people to check the sensors and data streams for their current annotated quality. After this tool has started, you can see a map of the city of Aarhus with all the sensors we have available in the city. Each of these red and green dots is a sensor, and you can, for example, click on them to have a menu with details. This color indicates the current quality value for this sensor. You can see this legend in the left corner with this colors ranging from red to green. So at the moment the quality metric H is selected, and you can see that these red dots have a very low quality, and these green dots have a very good quality for this current selected metric. Clicking on the sensor, you can see the service category of the sensor. For example, this sensor I have selected is from the category Aarhus road traffic. So it's a sensor that measures the average speed for cars and the vehicle count. So it counts how many cars have passed a special section on the road. Above we have a unique identifier for this data stream, and in this small table we can see the current and historic quality values for this stream. At the moment we have the H, the frequency, latency, completeness and correctness available as QI metrics. We have different time spans, we have the current values, we have daily values with minimum, maximum and average values, and the same on an hourly base. As you can see, we have now for the H and frequency, we have the minimum available QI values. So it seems there's a problem with the data stream. And opposite we have latency, completeness and correctness at the maximum value. If we select one of these green value sensors, we can see that this sensor belongs to the Aarhus road parking category. So this is the sensor measuring the cars within a parking garage. And here you can see that the H and frequency values are much better than for the traffic sensors. To select a different view for this map for another QI metric, you have this menu on the right side, and within the scroll down list you can, for example, select this completeness. And now the completeness is displayed on this map, and you can see that nearly every sensor delivers a very high quality for this metric. If we switch to frequency, we have the same problem as for the H, that most of the sensors are red. This is because the traffic data stream from the city of Aarhus is offline at the moment. But in addition, you can see that also these parking garages, which are displayed with this yellow color, are not fulfilling this quality requirements at the moment. With these other menus you can select the time span that is displayed on the map, for example the mentioned current values, the hourly base values or the daily base values. And on the right side you have also the ability to switch between average, minimum and maximum values. In this graphs below you can see the quality distribution for these different metrics for all the sensors displayed within this map. So you can see that most of the sensors have a very low frequency level at the moment. Same is for age, whereas the latency, correctness and completeness are 100% fulfilled for all the sensors displayed at the map at the moment. We have some different options within this configuration tab. We can switch some color scales for the map view and switch this red to green spectrum, and we can switch the data source. At the moment we got the live view, so this Quality Explorer is directly connected to our framework, but we have the possibility to upload some files, and then we can select here historic data that should be displayed. To upload historic data, we have this import possibility where we can upload some CSV files. In addition to this current view for the quality, we have integrated a time measurement possibility for our framework, which you can see on this tab. We have here the possibility to switch from offline to online mode. At the moment we are on the online mode, so it's directly connected to the framework and working with direct live data from the framework. We can here switch between different categories. For example, we now select this Aarhus road parking category. So this is the data stream for the parking garages of the city of Aarhus. As you can see on the left side, on the first graph, these are the average times for the Aarhus road parking category. So it's the average times for all the quality sensors available. This inner circle is this update live module, which takes about nearly 2 milliseconds for one average execution time. On these outer levels you can see that these are divided into other modules. For example, this green part here is the update of the fault recovery module we have included in our framework. And this fault recovery module is divided into 3 different parts. So we can here exactly see how much time is consumed for the quality update, for this total spaces value, or for the vehicle count. Above this diagram we have the average times for one single sensor, so not for the whole category as we have seen above. So this is only for this one sensor, but the graph is nearly the same. To select another graph, we can take this top-down list and select, for example, another sensor. So if you have seen this graph, it has slightly changed. Details about the sensor are displayed here with the address of the sensor. With this additional histogram, we can switch between the single modules and see the distribution of the average execution times. Yes, this was a quick overview about our Quality Explorer. If you are interested in it, just try it, it's online. Thank you for your attention.